Hey, what's going on everyone? This is Big Brace channel. My name is Amir and I want to thank you so much guys for all of the interactions and support that I've been receiving lately from everyone. And special thanks to all of the members of the channel. Lately, I've been receiving a lot of support from our members, and for that, I'm immensely grateful. Now, I want to apologize ahead for the sound quality that you're going to see in the next hour or so for creating the server file. Unfortunately, I haven't hooked up the right microphone. I have different microphones and yeah, I got carried away and the sound quality was not the best. So I really apologize ahead for that. And for the second part where we're going to create the client file, the sound is going to be fine. Just bear with me writing the server. Again, I really apologize for the sound quality. It's an honest mistake, and I hope you will be tolerant enough and supportive as you have always been. Once again, thank you so much guys for all of the support, the likes, the comments, and I hope you will enjoy this project. Hey, what's going on everyone? This is Big Brace channel. This is Amir with you, and now we're going to create our retro chat application coded in Rust. This application that I showed you in the last video, in the last demo video. And yeah, hopefully this is not going to take too long. We're going to create two different files, one for the client, obviously, and of course, one for the server. We're going to start by the server, but before that, we need to create a project. So let me go first to the place where I want to create my project. And I'm going to do cargo, let's do cargo new, and I'm going to call this one retro chat project like so. cd retro chat project, and I'm going to open this with Visual Studio Code. And we're going to start with Cargo.toml, obviously, because we will need some dependencies. So the first dependency I need is the Cursive Library. The second one is Tokio, and I'm going to explain all of those in details. And I need version 1, and the features here are going to be full features. Also, I will need the deserialization. So that's a library called Serde. And also I need Serde JSON. So Serde is a library that's used to serialize and deserialize data, basically. So serialize it to JSON format in order to be able to send the API for the API calls, and also deserialize it if we want that JSON format to be converted in order to be shown on the screen in the terminal, actually the message that we're sending. And also we need the Chrono. So Chrono is simply is going to be used for local date and time. Okay, so these are the basic dependencies that we need. Now let me go to the source, and instead of putting this inside the main, I'm going to create a folder here, actually creating a folder called bin. And inside bin, I want this, so I'm going to put the main here, and I'm going to call that server. That's the first file that I want to start with. And that makes perfect sense, because in order to start some chat application, we will need to start by the server, by writing the server. That's very useful for a lot of reasons. One of them being is the ease of debugging. So if you're going to make sure that the server is running, and if something is wrong, if you have any errors, that means that something in the client. So you're going to go to the client directly because the server worked perfectly before, right? So that's one of the reasons. Another reason is, of course, in order to run the client, you will need to have the server running in the background. So anyway, we will need to start by the server. So I'm quite sure there are a lot of reasons, but those are two of the reasons that just on the top of my head. All right, so first thing that we want to do, also, I don't know why I deleted the main function, so we can do like this, and yeah, whatever, we can keep that println like that. First of all, I want to import the required libraries and modules. And the first one I need here is the Tokio library. So the Tokio library is very important because that's going to allow us to have a synchronous runtime for managing the tasks and I/O operations efficiently. So you're going to send the messages, the users or the subscribers, if you want to call them, they're going to send those messages without blocking any I/O operation. You're not going to block anything, which means that that's going to be done asynchronously, okay? And the main function by default, the main function, this one in Rust by default, this is a synchronous, okay? Synchronous function, which means that in order to run something, that's going to block everything else. But we're going to transform the main function from synchronous to asynchronous function using the Tokio library. But we're going to see all of that a little bit later. But for now, let me just do the boring stuff first. So I need the net, and we can do like that. Let me just snooze the tab 9 for 1 hour. Right, so the net, that's, I need here the TCP listener and the stream. So that's for asynchronous TCP networking. We'll need always the listener to listen to a connection and the stream to broadcast the messages. So TCP, TCP listener, and TCP stream. Okay, that's the first one. Also, I need the sync for broadcasting. So that's a broadcast channel for the communication between all of the tasks. So here is the broadcast. And also I need the I/O, and that's just synchronous input-output utilities. And that's going to be a sync buff read extension, but we'll need them in curly braces because that's more than one. Also, I need the async write extension, not the read, that one. And finally, I need also the buff read, that's just for the buffer. All right, you can read here that this is a struct that adds buffering to any reader. All right, we're going to understand all of that on the road. So that's the first dependency. Okay, I'm not going to comment I'm not going to comment anything now, guys. You're going to find the link to GitHub repo, the link to the GitHub repo in the description. You're going to find a lot of comments. Okay, so don't worry about the comments. And also, if you don't understand anything, please let me know in the comments below. I always love to answer all of your questions whenever I can, of course. Some of you told me that I'm a Rust expert. I'm very far from being a Rust expert. I know Rust, I love the language, but I'm not an expert by no means, okay? So that's not true. Okay, so after Tokio, we will need the serialization and deserialization for the structured data. For that, I need the Serde or Serde, or I don't know how to pronounce it, so Serde, and we will need here the serialize and the serialize. Okay, also we will need the Chrono for the local date and time, okay, to work with the local date and time, Chrono, and here we're going to have local. Also, I need the error handling trait. So that's a trait from the standard library. And this error trait, by the way, represents the basic expectation of error values, okay? So that's very, very essential for error handling. All right, good. Now I want to have this attribute. So we're going to derive from 4 different traits. We will need 4 traits basically in the server: debug, clone, serialize, and deserialize. Debug, clone, serialize, and deserialize. Okay, so what's going on here with that hash? What's going on here? What's that? Okay, so let me explain this in a very, very simple term. So this right here is called an attribute. Okay, let me create a docstring. By the way, that's a docstring, guys. So you can write whatever you want here. You see, that's going to be that's not a comment. That's a docstring. That's an explanation for whatever function, trait, struct, enum, whatever you're going to have in your Rust code. So again, not again, let me start from the top. This right here is an attribute. This attribute is instructing the Rust compiler to automatically generate implementations for those 4 enums, for those 4 traits. Okay, so you have the first trait, which is the debug. This is going to allow the struct that we're going to create after that attribute. I'm going to call it ChatMessage, by the way. This struct is going to be printed for debugging purposes. The clone, for instance, the clone right here, this trait allows you to create a copy of an instance of the ChatMessage struct by calling a method called .clone. It's going to do that on itself. Without this trait, by the way, you cannot easily clone or duplicate any instances. The serialize, this one here, or this trait is going to help you to convert an instance of the chat message into a format that can be serialized. As I told you when we were writing this in the Cargo.toml file. And of course, a format that it's serializable like JSON or BSON. And with that, you can send this JSON file or BSON file to through the network to be written on a file, for instance. All right. The serialization is really commonly used with those formats only, JSON and BSON. But in this case, you would likely to be able to use libraries like Serde JSON. That's why we have actually added the Serde JSON as well. With the Serde JSON, you can actually serialize instances of the chat message to a string or a file if you want. In our case, we want just to serialize it in order to be able to send it through to the client. All right, so you just shut that. Let's close the Explorer and let's move on. So let me just add a very, very quick description here. Again, don't worry about the comments. So this is an attribute instructing the compiler to automatically auto-generate implementations for the 4 traits. So let's now create that struct, and I'm gonna call it chat message. And here I want the username, so that's the name of the user sending the message. I also need the content. I also need the timestamp. That's a string. And also I need the message type. So that's the type of message, user or system notification, because we're going to send notifications, for example, when some client or some user or subscriber is going to join the chat. We're going to send some sort of notification that's going to be broadcasted to all the users that this user has joined the chat. The same thing when a certain user leaves the chat. So we'll need to define the message type, either the user or either it's a message by user or a system notification. Awesome. So that's the chat message struct. Now I want to define an enumeration for the message types. So again, I'm going to take this one, I'm going to put it here, and I need now, instead of struct, I need an enum message type. And I want to represent a message from a user. So I need a user message here, and also I need a notification or system generated message notification. So system notification. All right, so that's a user message, whatever the message that you're going to send to your friend or whoever you're going to be chatting with. And that's the system notification. That means that whenever the user joins the chat, you're going to be notified of that. And the same thing when they leave the chat. Right. I briefly talked about Tokio, but now I'm going to talk about Tokio a little bit more even. So what is Tokio? Tokio basically is an asynchronous synchronous runtime for the Rust language. Okay, you need to know this by heart. That's an asynchronous runtime for the Rust language. What is Tokio? At least for now, just keep this in mind. Tokio allows you to write asynchronous non-blocking code, which is useful for handling things like networking, file input-output, and there might be other tasks that may take time but don't require blocking the entire program. Tokio allows you to write asynchronous non-blocking code. We said that you can write or send messages without blocking anything in the stack, in the queue, and everything is going to be working just fine while sending and receiving. So there is something going on in the background, but your messages are not going to be blocking anything in the system, especially those networking, file input-output tasks and other tasks that might take time. So simply we can say that asynchronous programming allows you to, or allows your program rather, to do other things while waiting for one task to finish. And that essentially improves the performance, especially in concurrent applications. So that's what asynchronous programming is all about. That allows your program to do things while waiting for one task to finish. So if I can change something in our synchronous main function, we said that in Rust, the main function is normally or naturally synchronous function, which means that blocking I/O. If you do something, everything else is going to be held blocked or frozen. Okay, so to change that from synchronous to asynchronous, you just add the keyword async. But before that, I need an attribute. The attribute starts by the hash sign, and you open close those brackets, the square brackets, and from Tokio I need this main annotation. That right here is a macro. So when you annotate the main function with this Tokio main, it does a couple of things for you. First of all, it creates a Tokio runtime. The runtime here is responsible for managing asynchronous tasks, like networking or timers, for example, and also scheduling them to run concurrently. The second thing using the Tokio with the main, this annotation right here, is that makes the main function asynchronous. So that basically allows you to use wait in the main function. We can use a wait here inside the body or the core of the main function. So you can call asynchronous functions and wait for them to finish without blocking the rest of the program. So that's the whole usefulness of the Tokio dependency here in our program. That's a must if you're going to write anything that it's asynchronous or related to chat or chatting application in Rust. Okay? Tokio is a must. You cannot do it without Tokio. I mean, you can. There are other dependencies, I believe, but Tokio is, the heart of any asynchronous application in Rust. Okay, enough me yapping, and let's move on with our application. An I/O driver backed by the operating system's event queue. Right, and a high performance time. All right, so go ahead and read the whole thing if you want, but I want to just move on with our function because we have a lot of code to write. So from that main function, I need to get a result. And the result here is going to take two things. Basically, the first is T. So that's the type that represents either success or failure. So T is success in this case. I need to be in the form of open close parentheses. And the second parameter is the failure, the error. So that's the E. So I'm going to have here a box. I'm going to do like so. And I'm going to have dynamic error. Now I want to bind the server to the specified IP import. So let's have a listener that's equal to the TCP listener. And we're going to bind here 127, where is it? 127.0.0.1 port 8082. But that's not all, because we need to do .await inspect, .await, like so. Then I want to display server startup message with formatting like you saw in the demo. So just not to waste time, I'm going to copy that. Just put like this. All right. Now I want to create a broadcast channel for message distribution. So here I'm going to create a broadcast channel for message distribution, and that's of course essential. Again, guys, we are writing the server. The server is the core of the application. So that's going basically to allow multiple users to receive the same message. So if you are connected, your name is John, for example, and I'm Amir, and we have Nancy. If you're writing hi, me and Nancy are going to see the same message. Okay, so that's basically allowing multiple users to read the same message you wrote. Then I will define a buffer size of 100 messages. And I'm going to create the main server loop to handle all of the incoming connections. So that's the main loop. Let me just shut that to. So inside the loop here, we have the socket, which is TCP stream, the address, which is the socket address, equal to the listener.accept.await. Again, by having this annotation, the main with the Tokio inside that little macro, we will be able to write all of this await. This one, all of those await keywords inside the main function are very important for non-blocking I/O. Sweet. Now I want to display connection information. So that's, by the way, that's here accepting the connection, and here I want to display the connection information, and I'm printing them in this order. So I have here a placeholder, that's a curly brace new connection, that's the local now.format with the hour, minutes, and seconds. So here is the hours, minutes, and seconds, and the IP, and the IP address here. All right, so that's actually what I'm printing to the console whenever there is a new connection by the client. So you, for example, John, you are connected. So you're going in the server, if you will check out in the server tab, you're going to find that new connection here with the time and your IP address. That's not all, because now I want to clone the sender for this connection and subscribe a receiver. So that's what we're doing here. We are having a sender, which is the TX, and a receiver, which is the RX. So you're cloning a server and clone and subscribe a receiver here. So you're cloning a server and subscribing a receiver. All right, so that's very, very important to create a sender and receiver variables. But that's not all. That's not the end. Well, actually, what I'm going to write now is the end of our main server loop. So I want to spawn a new task to handle this connection asynchronously. Okay? Don't forget asynchronously. So Tokio or Tokio.spawn, and we are spawning here. So that's called a future message, right? A future notification, a future whatever. So we are moving asynchronously, and here I will need to invoke a message that takes the socket, the sender, and the receiver. Initially, let's call it just in you know what? Let me actually do like that all together, because that's going to be called handle connection. Let me actually exit the server loop and create a function to handle the handle. A long time I haven't typed on this keyboard, but I love it because it has very crisp sound. Connection, the client connection, or yeah, an individual. Each client connection is going to be handled individually. So I'm gonna call that handle. That's an asynchronous function. Again, don't forget handle connection, right? And that's going to have three main arguments, parameters rather. The first one is the socket, and the socket here is the TCP stream. TCP stream. That's the first one. So that's the TCP connection for the client. The TX, and that's going to be broadcast, the broadcast sender, and I have here a string, and that's essentially the sender. Shut that first. That's essentially the sender. Just shut all that. I don't know, it's complaining too much now. It looks ugly. Yeah, that's the sender for broadcasting the messages, and also the receiver for all of the incoming broadcasts, all of the incoming messages. That's going again to be a mutable variable. Broadcasts receiver string. All right, so I want to split the socket into reader and writer. I want to say, or want to declare, reader, and the writer is going to be mutable, but not the reader. And that's equal to socket.split. Next, I want to buffer the reader for efficient I/O. Buff reader new, and we are taking that from the reader. Oops. That's really annoying sometimes because I don't see from the notifications of the Rust analyzer. And finally, I want to store the username sent by the client, because when you're going to run the client file, you're going to have an obligatory argument, as I told you in the last video. You're going to write your name essentially. So we have a username, reader, and we have mutated the reader, and also we have the writer, which is mutated as well. So the reader and writer as mutable is equal to socket.split, because we want to split the socket to reader and writer. Now the reader, we're going to have it as a mutable variable, and that's equal to the buffer new reader. That's essentially buffering the reader for the I/O operation. And the username, which is a mutable variable, initially or essentially to store the username sent by the client. And now I want to read the username sent by the client. So here I want to, always doing this crazy stuff. Here I want to read the username sent by the client, by the user. So here, reader.read_line. That's a method. We're going to pass here the line itself. So the line in this case is the username. So that's mutable reference to the username, right? And also we're going to have the await keyword dot unwrap, yeah. Okay, I'm trying just to make it cleaner for you guys. And also I want to overwrite the username to be equal to usernames. Here I'm actually removing the extra space or new lines. So I'm reading the username and I'm cleaning it. I'm trimming any extra spaces. So username dot a method called trim dot toString. So I've actually read the username and cleaned it, trimmed any extra spaces or new lines. Now what I want to do is I want to send a system notification indicating the user has joined. So send a system sys notification has joined the chat. To do that, I want to declare a new variable called join message, and that's going to be equal to the chat message struct. And here I'm going to define each of those fields. So the username is username.clone. Next, the content, and that's, we can say here, joined the chat, not the chant. And don't forget to convert that to string, Next, I want the timestamp. So we need the timestamp and the message type. Again, we said whether it's a message by the user or system notification. So the timestamp here is going to be local now format formats with this %, hours, %, minutes, %, seconds, %, seconds. And also I need to convert that to string. And finally the message type, and that's equal to message type system notification. Apps. All right, hopefully this is clear for you guys. That's not all, because also I want join JSON, and join JSON actually is going to take the Serde JSON dependency or package, and we're going to have the toString, and I'm going to pass inside the join message. Okay, so that's actually a reference to join message. So that's the join JSON simply. So we have join message and the join JSON passing inside the join message to convert that to string. So again, serializing and deserializing to transfer whatever the message that you're writing to a JSON format, and deserializing to change it from a JSON format to a readable message on your terminal, on to the console. So that's the main purpose of JSON and JSON. So that's, and again, the serialization and deserialization is a very practical way for converting the text to JSON format and deserialize it from JSON format to the format that you can actually read on your terminal to the console. So after join JSON, I want to send join JSON. Okay, so I need for that the sender. The sender is the tx dot send, and I want join JSON here dot unwrap. By the way, let me check out if I'll do cargo run bin server. We have an error. Let rx equal to tx. Oh, okay, wait, hold on. Remove the mutable. This can be immutable. Okay, so that's the most important. This is the error. Those are warnings. You don't care about the warnings. Oh, that's better. All right, so let's run that again. Oh, okay, awesome. So we haven't run or bumped into any errors. Awesome. Okay, so Control C to shut down, and let's move on. So what I want to do next is I want to initialize a buffer for incoming messages from the client. So I want to have a line. Let's make it immutable because that's going to change, right? So lines are can change. So let's string new. So that's a mutable line. That's a variable here. So that's the first one. And again, I will have another loop. And inside the loop, again, I'm going to take Tokio and I'm going to access the select. And with the select, I will have to handle the messages sent by the client. So if the client has already disconnected from the chat, I want to break outside of the loop or exit the loop. So the way to do that is I want to have the result. And the result here is equal to reader.readline method, and we're going to pass inside the readline method the line itself. Okay, so the one that we have actually defined here, but we're going to have a mutable reference to that line. So I will need to use the ampersand mute keyword with the line variable. Now, if that's the case, I want to check out if that result dot unwrap is equal to 0. In that case, I want to break outside of the loop. Now, I want to create a user message and broadcast that message as well. So create and broadcast user message. So here I want to declare a variable called message, and the message here is equal to the ChatMessage struct. And again, we will need to have our 4 fields. The first one is the username. That's the username dot clone. We're cloning the username actually of the person or the user who is writing the message. Also the content. And that's equal to the line.trim for extra spaces or new lines, and we're converting that to string. So I need here a timestamp, and the timestamp, as always, we can actually borrow that from here. Can actually, what have I done? I can take both of those lines and I can make like that. Just move them like so. And of course the message type here, in this case, not system notification, but rather a user message. All right, now I want to have the JSON itself. So the JSON is equal to the Serde JSON, and that's actually accessing to string method, and we are passing here a reference to the message. But that's not all, because we will need the sender to send that JSON dot unwrap. And also I want to clear the buffer for the next message, so I will clean or clear the line rather. So line dot clear. And then the last thing in that loop that I want to do is to handle the incoming broadcasts and send them to the client. So I want to handle the incoming broadcasts and send them to the client. So the result here is equal to the receiver dot receive this to be clean. Okay, and I'm going to just I made something wrong here. I don't know why I made it like that. All right, so the result here is equal to the receiver dot receive method. So we will need to have different things inside our that little function, or that function stored in our variable result. So first of all, I want the message to be equal to result.unwrap. Now, to handle the incoming broadcasts, I will need to use the writer. So the writer here is going to write half, or write all rather. Write all, and inside write all we'll have the message itself as bytes, in form of bytes. And that actually, this as bytes returns a slice of the content of the message. So yeah, if you will hover over here, it will tell you that it returns a byte slice of the string's content, or the message, I mean. And the inverse of this method is from UTF-8, or we can do that. The inverse of this method is from UTF-8. Okay. So message.asBytes, returning a byte slice of the content of the message. And that's not all, because we want to do the await. First of all, don't forget to call that function by having the parentheses dot await dot await dot unwrap. All right. Also, I need the writer to write all again. And by the way, for those of you who don't know the write all method, if you will hover over write all, it tells you here that it attempts to write an entire buffer into this writer. So this method will continuously call, we can do that, sorry for that. This method will continuously call write until there is no more data to be written. Now, the last thing that I need to do is I need to handle how to send the notification indicating the user has left. Above here, we have actually written how to send the notification, this right here, whenever the user has joined the chat. So we're going to clone the username. We're going to say, instead of join the chat, we're going to say left the chat. Also the timestamp, that's going to be the same thing, and that's a system notification, not a user message. For the join JSON, we're going to keep it as it is, but instead of join message, we're going to have leave message. All right. So I haven't actually changed it here. So leave underscore message. And of course, don't forget to change that here. That's not join, that is leave. How we can do it like so. And that's basically everything. Well, the last thing we can do actually is to log the disconnection information to the console, to your terminal. Disconnection info the way to do that is by println. All right, that's simply it. We are actually saying that at that time, at that local time, this user has disconnected. And for that placeholder, we will have here the local time, and the placeholder for the user that's going to be there, right here. All right, the last thing that I forgot actually to do is after I've written the handle connection function, I haven't actually invoked it inside here, inside our broadcast loop. All right, so let's actually invoke that. So what I want to do is I want to move any future message using the handle connection function that we have created. So again, Tokio, this is very annoying. Spawn, okay, async move, we're moving the future, right? Any future message or, you know, line, content, whatever. And here, oops. And here I want to use the handle connection method, and we have the socket, the sender, and the receiver. And of course, don't forget the wait, because we have here this asynchronous keyword. So don't forget to do a wait. Oops, do like that. Right, so that's basically everything. Actually, I believe that there's something wrong here. Yeah. It should be above, if I'm not mistaken. Yeah, that looks right to me. All right, so moment of truth. Let's do like that. No, not opening this. Just minimize. Let's run the server again and let's see if we'll have any errors. And we don't have any errors. The server is running perfectly. Awesome. In the next part, we're going to write our client and start sending messages and testing the interaction between the client and the server. So congratulations, you have written a chat server in Rust. Give yourself a tap on the back, go get yourself a cup of coffee or tea, and get back, open your VS Code again, for a new file where we're going to write our client and we're going to test it, writing the messages and interacting with the server. I will see you in a bit. All right, guys, welcome back to the second part where we're going to create the client side of the application. Once again, I apologize for the sound quality of the server video. I've noticed that, unfortunately, too late. And yeah, hopefully I've corrected this before the video ends, and at least you will enjoy a little bit of good sound quality. All right, so let's go ahead and start first of all by importing various modules from the Cursive Library for UI development. Now, if you don't know what the Cursive Library is, I have a full crash course on Cursive Library. I've also a project where we've created the Pomodoro timer application, also a separate video where we have built together the inventory system also using the Cursive Library. It's an awesome library. So if you don't know what Cursive Library is or what Cursive is in general, in a nutshell, Cursive helps you to create TUI applications. That's it. TUI stands for Terminal User Interface, and if you've been following my videos for some time, you must know by now that I love CLI applications and TUI applications, command line interface applications, and terminal user interface applications. In Rust, the Cursive library is very famous, but there is another one called Ratatouille. And I remember I've read a couple of comments. Some of you guys asked me to do a Ratatouille project. Well, unfortunately, I haven't had the time to discover Ratatouille yet. But I promise you that I'll give it a look, and eventually we can create a crash course on Ratatouille and a couple of projects. Why not? All right, so let's go ahead and start by importing the various modules from the Cursive library for the UI development. All right, so I'm going to use Cursive Oops. And here, just increase that a little bit and stop that the tab 9 annoyment, and maybe just make like that. So the first thing that I want to import is the horizontal alignment utilities. That's the first thing. Also, I need the key. That's basically to handle the key press events. Also, I need the theme, and the theme basically is going to be used to create the retro style theme function here. Let's push that to the bottom, and here let's have our main function. And here that's going to be that's the first thing that I'm going to start with after we are done importing all the various modules. Then we're going to get to the bottom of the main function. By the way, that's going to be also Tokio, exactly the same thing that we have done in the server side, and that's going to be also an asynchronous function, right? And that's going to well, we'll keep it like that for the moment. Let's get back just here and have the theme. And here I want different utilities. So I need the border style, I need the palette, I need the theme, obviously, I need the color, I need the palette color, I need also the base color. Awesome. Also, I need all of the traits, so I'm going to import everything, right? Some additional traits for UI components, nothing more. Also, I need the views, so let's do like that. And let's have what? First of all, let's have the dialog. Let's have the edit view and the scroll view. Scroll view for scrolling the messages, also the text view. Let's have linear layout. Let's have panel, and let's have dummy view as well. Let's put it here. Awesome. And finally, don't forget to import just the main cursive application object. All right, so that's importing those modules from the Cursive Library. Well, we're going to do the same exact thing like we've done here in the server, where we've imported from Tokio, Serde. We need that, actually. The Serde and the Chrono are going to be exactly the same. As far as Tokio is going to be changed a little bit, so yeah, maybe we can write that, or we can change it. Let me just copy. Get back to the client. Let's do like that. So I'm going to change here a little bit. For the network, I don't need both of them, the TCP listener and the stream. I only need the stream, just for the TCP connections. So let's just delete that. Let me just delete this as well. And the IO here, I need the async buff read, write, also the reader. So I'm not going to change any of that. That's for the async IO utilities. And for the sync here, I need not the broadcast, I need mutex. Mutex or mutable exclusion, I've explained that many times in different applications. Simply that provides thread safe mutable access. Okay. When we're going to write the mutex, I'm going to explain more. That's just theory. And in order to understand better, you need to see that in action, in practice, right? So there's no use of telling you some theory here, because I'm going to talk a lot, and that's actually counterproductive sometimes. Also, I want to import some necessary standard library modules. So let's have here from the standard library, I need the environment, I need the error. From the error, I need the error here itself, and I need the arc. I need the arc from the sync. Okay. And that's actually everything. that's everything that we need to import. Also, I will need to have the struct, the same struct that we had in the server, also the enum. So let me just have the struct message and the enum. Just copy that part. That is exactly the same. That is exactly the same, guys. All right. Derive the debug, clone, serialize, and deserialize all of those elements. And that is just the struct to represent our chat message, and that here is the enum to represent the different types of the messages, the user message, and the system notification. All right, we explained that in the last part. Hopefully that was clear to you in the last part. I'm not talking about the sound quality, but the explanation itself. So yeah. So in a nutshell, we will have here a username. That's the username of the sender. In the content, that's going, of course, to be a string as the username. That's the message content. The timestamp, also string data type, timestamp of when the message was sent, and finally the message type, which is whether it is user message or system notification. All right, that's basically it. And for that main function, let's just push this a little bit. Oh, I forgot. We need to create that first. Okay, it doesn't matter. Let's just have this here. I need to return a result. And the result here is going to be either okay, just close this, or with error. So box dynamic error. Just shut that, and that's it. Let's go to the retro style theme, and let me call this one create retro theme, for example. So create retro theme, and that is going to get us a theme that we have imported above from the theme module. And as far as the retro theme function, I'm going to do that on multiple steps. So the first step is by creating or declaring a variable called theme, default, right? And I need to enable shadows. So I'm going to set the shadow to true. So yeah, theme.shadow is set to true. And also I want to use simple borders. So theme.borders is equal to border style accessing simple. All right, so that's the first step. The second step is by declaring another variable called palette, because the theme is not useful without the palette, right? So let me declare that mutable variable called palette, and that's equal to the palette, right? Default. By the way, if you cannot tell, I've changed the keyboard because the other one was too noisy and distracting me, to be honest. So yeah, I prefer the membrane. Sometimes I like the mechanical keyboards, but in general, I prefer more the membrane keyboards, especially this low profile Microsoft keyboard, which is very good for productivity. You don't need any noise or distraction. You need just to get things done and have your code written on your editor. Here I'm going to have different colors. So that's going to be, this is a very boring part, by the way. This is like you're writing your styles.css file. Yeah, bear with me. I'm going to attempt to do this very quickly with minimum talking. All right, so I need the background. And the background here is deep blue background. So this is red, green, and blue. And the RGB values here are going to be 0, 0, and 20. Right? That's for the background. Also, I need for the color for the views. So that's also going to be a deep blue color. But I need to change that from background to view. That's all. Also, I need the primary color. That's exactly the same thing that you would have done in Bootstrap, for example, or CSS, right? You have your primary color, your secondary color, and so on. So that's the primary color that we have. We want it to be bright green text. Okay, you're free to choose and experiment with whatever color that you prefer, but I'm going to keep it that way. So instead of the 0 for the green, that's going to be 255, and we're going to keep that at 0 for the red, for the blue, sorry. Also, I need the title primary. So title primary, and I want that to be green. So that's 0, correct, 255 and 128. Also, I need the secondary color. And here, that's going to be 255. And yeah, let's put this 0, and that's 191. And also, I need for the highlight. And for the highlight, that's going to be a cyan color. So that's, oops, that's 0, 255, oops, what just happened? Okay, 255 and 255. All right, awesome, that's for the highlight. And finally for the highlight inactive, so I'm going to add just the word inactive here. And I'm gonna give that a dark cyan color, so that's 0, 128, and 128 as well. All right, and that's about it. Three remaining things, sorry. I need the subtle shadow, so I need also a shadow. So the last one, that's going to be the shadow, because I need some subtle shadow here. So shadow, oops, that's a capital S. And the color here is going to be 0, 0, and 40 for the blue value. And that's about it, guys. That's for the solid shadow. Also, I need to apply the palette. To do that, you take the theme.palette and you assign it to palette. All right, and just have your theme here. And that's about it. That's your function. That's the function that's going to create retro style. We're going to use it later. All right, back to our main function. So first I want to fetch the username from the command line arguments. If you remember in the demo video, to run the client file, what you will need to do is to just say cargo run the name of the folder that's going to be in the bin folder, right? Inside the bin folder, you have the client file. Following that, your name, right? So that's the obligatory argument. Without that, you won't be able to join the chat. We will need the name. And that's what we're going to do now. We're going to fetch that name, that username, from the command line arguments. And that's going to be the second argument, actually. The first argument is the name of the file. That's going to be inside the binary folder here. Let's move on by declaring that username variable equal to env args. And here I want to just get the second argument, as I told you, after the program name, right? After the client file. So that's nth and 0, that's the first argument. We need the second argument, which is 0 is the first index of the first variable, and 1 is the second index for the second variable. All right, so we need 1 actually. .nth also .expect. So .expect is going to exit if no username. We're going to prompt the user with a guiding message, something like please provide a username or something like that. So that's expect here, and we're going to enter that in a form of a string. Please provide a username as argument. All right, so that's the username. Next, I want to initialize the Cursive UI framework. Initialize the cursive object, right? Or we can say the Cursive UI framework if you want. And don't worry about the comments. Again, you're going to find the file in, the GitHub repo in the description below, the link to the GitHub repo in the description below, and you will find the code is heavily commented, so don't worry about the comments. All right, so what we need to do is to declare that mutable variable sieve, and we have done that many times in our cursive projects. So cursive here from the default, and here I want to apply the custom retro theme that we have created. That function here, we're going to apply it right now. So you're taking the sieve object or the cursive object dot set theme method, and you're passing inside your function that you have created. So the create retro theme, you're invoking that and passing it as the main argument inside the set theme method. All right, you're basically applying a custom retro theme here. Next, you want to create a header to display the chat title and the username. So create So here, let me declare that variable header, and the header here is equal to the text view, obviously, and we want new format. And the format here is going to be like so, retro chat, and we want the user, whoever the user is, and the time of connection. So I need two different variables or two arguments here, the username and the local time. All right, so we'll do like that, and just make it like this. The indentation, of course, is not important in Rust. It's a Python thing, but for me, it's more of organizational thing, just for my eyes, to not get lost. All right, so here I need the username. And the username here is going to be whatever the username that you're going to pass as command line argument. And the second variable or second argument here is the local time. So local now, and we're going to format that as always with the %, hours, %, minutes, %, seconds. All right. And that's as simple as that. Now I need to use the styling of my create retro theme function. So I need the style. So the style here, the color light, and we need the base color to be color. Right? That's just for the green text for the retro look. And also I need the horizontal alignment, h_align, and that's the h align here, and center. That's just to center align the header as you saw in the demo. All right, that's basically it. Right, now I want to create a message area with that scrollable text view. To do that, simply let's just add that comment just for separation and clarity. Let's do creating the message area with a scrollable text view. Sweet. To do that, let's have a messages variable equal to text view new and open close and empty strings like so. That's to initialize empty text view basically. But we need a name, we need minimum height, and also we need to enable the scrolling. And again, it's nothing to do with indentation. It's just that's better for my eyes at least. So to each their own preference, right? So I have here with name. That's going to be messages. That's to, assign a name for later access. I need the minimum height here. Let's keep it 20. That's the minimum height for the message area, guys. And finally, I need that to be scrollable. Right? I'm enabling the scrollable capability. So for you to check out all of the messages, if you have written a lot of messages and you need to go up or down, you can scroll that easily. And again, I'm going to say let messages equal to the text view, not the text view, the case that's going to be scroll view. Scroll view, and we have here new and passing the messages, right? And also I need the scroll strategy. Scroll underscore strategy. I'm really happy without the Rust analyzer, by the way. I don't know about you, but that's really annoying for me. This is much better. Scroll strategy. Not that one. Scroll strategy. And here stick to bottom. And that's simply to keep the scroll at the bottom. That's all. And also I want to have minimum width. So minimum width that's equal to 60. And of course, don't forget to have a full width, just to occupy the full width of the parent. So full width, by just invoking that right here, you're actually enabling the full width functionality or capability. Next thing that we want to create in our asynchronous main function is how to create basically the input area for typing the message. To create an input area, we will need an input variable. So input is equal to the edit view, new here, and we will have to define the submission behavior. So we will do on submit, and with the on submit right here, we will move and also send underscore messages s and text to string. So that's the first method. Also, I want to assign a name for later access. So we'll do with name, and here we'll say input. Also, I need the maximum height just to limit the input height for 3 lines. Okay, so we're not going to write an email, right? So maximum, that's going to be 3 line only. Maximum height is 3, and the minimum, let's have a minimum width to 6. Let's make it 50. And let's occupy again the full width for of the parents. So full width is just activated. All right, and after that input area, I need to have the help text for the user commands. So let's have also comment here, creating help text for user commands. Let help text equal to text view new, then we'll say here escape to quit, and we'll have enter to send. We'll have here commands. We'll say here /help and /clear and /quit. Right, all that dot let's just make it here, okay, dot style, and I'll have here the style color dark, and the base color is set to white. I know I'm a bit pedantic and I apologize for that, but yeah. All right, so that's as far as the help text is concerned, and don't forget the semicolon. All right, now I want to assemble the main layout. Obviously, I will need to have a layout variable, and that's going to be equal to the linear layout, accessing the vertical, and we're going to have a header panel. So I need the child, and inside the child I need to have panel accessing new header, and need here to have the child, and let's just have that because that's going to be a bit messy. So the dialog, that's the dialog box for the messages, dialog here around messages, right? Also I need the title, so we're going to say, wait, hold on, let's do like that. Okay, Let's have here title, messages. Let's center align the title just to make it in the center. So let's have that title position, title underscore position, and we'll have here horizontal align to the center, right? And finally we'll have a full width. So we're going to invoke that like so, and we are done with our layout. Now, and we're not done with our layout. We'll need to have another child to have a dialog box for the input. So we're going to have another child like so. I have here a dialog around, not messages this time, that's going to be input dot title, and the title here again is going to be not again, but that's going to be message actually, because that is the input, right? One message. And also the position, it's going to be to the center. So maybe you can take that. I'm going just to put it here and delete this. There we go.
Another one maybe.
All right, so that's as far as the header, the messages, and the input message. And finally, I want the last child for the panel for the help text. So panel, new help text, dot full width. All right, that's the help text panel. Right, now I want to wrap the layout for centering. So let me again declare a variable called centered layout. That's equal to the linear layout. From here, I need the horizontal. Yeah, okay. Sometimes I misspell while I'm typing, and that might cause some potential errors. So do here again child, and I need here the dummy view dot full width. Right? That's the dummy views for spacing, nothing more. Also, I need the layout, so child layout, and also we want the full width. So wait, hold on. Yeah, we need the full width. That's right. Dummy view dot full width. That's actually wrapping the layout for the centering, but we also need to add the centered layout to the cursive root, and that's by taking the cursive object, just do like here, taking the cursive object and having this add full screen layer, add full screen underscore layer, and inside the add full screen layer I want the centered layout. Now I forgot to tell you that so here the send message, maybe I forgot to mention that. Wait, right, so we have send the message, wait, this one here. That's not a given. We will need to create that, by the way. I just forgot to mention this. All right, so let's just keep that at the corner of your head. Don't forget about that. We're going to get back to it later. All right, now I want to add global key bindings. So again, I'm going to adding global key bindings. Right, so again, I'm going to take the cursive object and I'm going to have here add underscore global callback. So add global callback, and I'm going to pass here the key to be escape. So whenever you will hit escape, you're going to exit the program, and as like so, s.quit. So that's basically escape, right, to quit. That's all. Also, we will have the /, so we'll need that by also add global callback method, save.add global callback, and here we'll have this /, also that s, and we'll open curly braces and we'll say s dot call on name, not call underscore name, like so. And here we will have the input view, view, that is actually a mutable reference to the added view. So that's a mutable, where is it? The mutable reference to the added view. And here we will insert / just in the input box, and after that the input that whatever you want to write after, clear or help or whatever. So what have I done actually? Edit edit view, right? And we want just to close that here like that. That's right. And we'll open curly braces. We'll do like so. Awesome. Now we want to have the view dot set content. Oh, we don't have it. Set content. Okay, and that's /. Okay, so that is inserting the / in the input box. That's all. Don't forget the semicolon, the semicolon. Next, we want to establish a connection now to the chat server. That's the most important part, right? We need to establish a connection with the server. How to do that? I want to again initialize a variable called stream, and the stream is that's actually the main stream that we're going to use to split that into reader and writer. So we'll have the TCP stream. That's the only one. We don't have the listener, right? The listener is on the server. And here we're going to connect on the local host. So 127.0.0.1 on port 8082. On port, what's going on? 8082. Right. .08. Then we'll have here a reader, exactly the same thing that we have done in the server and mutable writer, and that's equal to stream.into split into, cannot type today, into split. Again, that's going to split the stream into reader and writer, and for the writer, we want actually to send the username, right? So I need the writer dot write all, and here I want in that format, right? And that's going to be the username, right, as bytes. So we're sending actually the username. So we'll do like this. The new line, and here is the username as the main argument to be the placeholder actually. And yeah, that's basically, oh yeah, and as bytes, don't forget that. So as bytes, and we're going also to await for a response. All right. that is actually a thread safe writer. So Amir, what the heck have you written here? What is that? What's the arc, new, mutex, whatever? Simply that arc, this arc here stands for atomic reference counting. This arc t, actually that's arc t here. Arc t. This here, maybe just to make like that. This right here, that's actually stands for atomic reference counted smart pointer. Okay, that allows simply multiple threads to share ownership of the same data. We have seen that very clearly in the Pomodoro timer application. Unlike RC, there is RC, so there is the atomic and there is RC, like that. This one here, this here, actually is a single threaded. That's not a thread safe. This is a thread safe. The atomic reference counted smart pointer. That's a thread safe because it uses atomic operations to manage the counting of the references. All right. Also, we have this very weird term, mutex. What is mutex? I told you in the beginning when we have imported that stands for mutable exclusion. Okay, simply is a synchronization primitive that ensures that only one thread can access the data at a time. And that's very important. Otherwise, you're going to run into errors. It actually prevents the data races. That's type of bug called data races in Rust. Also, I talked a lot about it in the Pomodoro timer application, in the inventory system project, also in the not in the crash course, in the full course, in the Rust full course. I spoke about the types of bugs, especially data races. So data races happens when more than one thread try to access the data at the same time. That creates the type of bug. So long story short, that mutex right here, this basically prevents those data races, which means many threads try to access the data at the same time. And how so? By locking or isolating the data, allowing only one single thread to mutate it at any given moment. This is very effective and it's going to just save you the trouble and the anxiety of having potential errors and bugs in your system. Because as you know that Rust is a systems programming language. It's not a language that you can write with it a simple project or simple program. And I've read that Linus Torvalds, the founder of Linux/GNU, well, GNU project is by Richard Stallman, but whatever, because Richard Stallman always asked us to mention that the GNU project should be also mentioned when you mention Linux. So anyway, Linus Torvalds said that he loves Rust programming language so much that he's actually has decided to include it in the kernel. Actually, there is a rise of creating those software or those programs using Rust programming language that you can find in any Linux distros nowadays. So, all right, let's get back to our code. So that's basically the writer, right? That is a thread safe writer, allowing multiple threads to hold a reference and using the mutex to ensure that only one thread can modify the writer at a time. Together, they allow safe concurrent access to a single writer, which actually what we need. So now we want a writer clone. Writer clone for later use. So arc clone, and we are referring to, I need the writer, the reference to the writer. Okay, so that's, as I told you, that's a clone writer. And I also want to store the writer in the Cursive app data. To do that, I need the set user data here, set user data. That's also annoying to not find or autocomplete the name of the function or the method. That's also annoying. So keeping it away is annoying, and not having it is annoying. So we're going to pass in the set user data method, we're going to pass the writer, and don't forget the cursive object. Now I want to wrap the reader with a buffer, so I will have here a reader, and that's equal to the buff reader. Mutable variable for the lines to, have the line reader basically. So reader dot lines. And also I want to clone the cursive callback sync. So that's the sync, as we always do, not synl, sync. I'm feeling I became blind. I don't see very well here. CB underscore sync dot clone. So again, we are cloning the cursive callback sync. And now I want to spawn an asynchronous task to handle all of the incoming messages from all of the users. So spawning a sync task to handle the incoming messages. Therefore, we will need Tokio, and we'll have here spawn async move. So I'm going to say while let OK some line equal to lines.nextLine.await. We're going to check out if let OK message equal to Serde JSON from string, the chat message itself, and line reference to the line. Let formatted message equal to match message.MessageType. The message type is a user message, not a system notification. In that case, we're going to format it this way. So we're going to check out the timestamp first, the username, and the content of that message. And also for the system notifications, it's going to be the username and the content, right? Only two placeholders. If sync.send box new move the cursive and mutable cursive, save.colon_name messages view and mutable reference to the text view, we are actually appending to the view the formatted message. And if there is an error, we're going to break outside of the while loop. So what the hell is going on here? What is that code block? This code block here runs the asynchronous task using the Tokio spawn. All right. It actually continuously processes incoming lines from an asynchronous stream. So the lines.nextLine.await here, that is the asynchronous stream. And each line is parsed as a chat, as a chat message using the Serde JSON, okay, to send, to serialize and deserialize, right, as we know, to serialize and deserialize, as you know. And depending on the message type, whether it's a user message or a system notification, the format of the message is going to be different. In case that the message type is a user message, the user messages are displayed with a timestamp, username, and content. Otherwise, the system notification, that's going to be displayed as a separate formatted notification, right? That the username has left or the username has joined. Those are the two notifications that we have basically. And once formatted, the message is sent to update the UI using that sync.send, which actually modifies the cursive user interface text view. All right. And if the sending of the update fails, we're going to break outside of the loop. And don't forget to run the cursive event loop. Doing save.run, and we are done with that. And also let underscore equal to writer clone dot lock. I'm gonna explain that in a second. Lock.await dot shutdown, not shit, shutdown dot await. So what's going on now? Simply we are closing the writer and we are exiting successfully. By the way, guys, and before checking the last function, the send messages function to handle the messages, I made the most stupid, silly mistake. Just an honest mistake. That's cursive with it's not capitalized, of course. That's the cursive crate, and also this crap right here. Not a semicolon, of course. Those are commas. All right, and I really apologize for that. Also here, that silly mistake. This is outside here. I have this right underscore all. There is an error here, missing that semicolon. Also for the Tokio spawn here. I don't know why the hell I've done that. Or that was just by mistake. I'm not really sure, because we need to make like this, and that's it. That's fixing the problem. I really have no idea why Tokio spawn async move was doubled. Also, this one is not send messages, but send message. All right, you'll find that that has disappeared. This error has disappeared. And what is wrong here? That is, instead of double quotes, should be single quotes. All right, so that's another error. Let's see, what do we have else? Let's back above here. Let's see. Color, no variant or associated item color found for enum base color. And that, of course, is correct, because I didn't mean to write color. I meant to write green. Right. Next, what do we have? We have here white. So that's with W capitalized. And finally, we have what? Chat message. That's not correct. Right. So I think I have forgotten to, when we have actually copied when we've actually copied the struct. So we have it derive. Oh, that's for the enum for the chat message. Okay, so we have 0 implementations. Yeah, there we go. That was the main error. Right. And now we should not, or we should be fine. Yeah, it has disappeared here. No more red lines. Awesome. So the final piece of code in this application is sending the message. That's the most important part, I believe. So this function here is going to process the message input from you as a user and other users. It's going to check for specific commands like help, clear, and quit. And you can see that on each code block, there are some instructions. So save.call on name, messages, view, mutable text view. It's going to append, and we're going to check if commands is equal to help. We're going to show this help, and for clear to clear messages, quit, just exit the chat. Okay, so that's for the help. That's for the clear, where we're actually clearing the content. And quit, just to quit the chat application altogether. And if the message is valid, basically we're going to send the message asynchronously and clears the input field in your UI. That's basically everything here, guys, for sending the message. All right, now let's check out our application. So let me open the terminal here. Okay. And let's go to my location, not this one, retro chat project. And let's do cargo run, not cargo. Let's just do like this, cargo run -- bin client and the name of the user. That's the argument that we need to enter. So let's say Bob, for example, and take a look to the server once I hit enter. Do you see that? New connection, right? It's listening on new TCP connections, and Bob joined the chat here. Awesome. Let me also let's do like this. Let's have another one. Okay, let's do this. Amir and let's do cargo run instead of Bob. Let's do Sue. Okay, and another connection. And Sue can say hi Bob, and Bob actually is seeing Sue's message. All right, and we can do like this, and they can talk to each other. Hi Sue, where are we? Hi Sue. All good. What up? Rust is awesome. C is better. No, Rust is better. And then Sue is going to be upset. Okay, gotta go. I'll leave you with Rust then. And she can do /quit or simply hit escape button. And that's it. Sue left the chat. All right, we can now try the clear. That's working. We can try help. That's also working. We can try quit. And that's also working. And you can see here Sue disconnected and Bob disconnected. And that's all. Thank you so much guys for watching the whole tutorial. I appreciate all of the support, the likes, the comments, the interaction. And I will see you in the next tutorial. Till then, stay safe and be well. Don't forget to drop your comments, ask your questions, and let me know what you think about this application. See you later guys.